Hello everyone. So today I'm going to be working on this physics JAMB series. So these are compilation of past questions. Yes. And I'm gonna take you through it from start to finish. If you are happy, just send me emoji. Remember to follow, remember to subscribe. Our YouTube channel is TM Pro Academy, right? Try to follow and subscribe, and then I will see you as we run through this perfectly well. So nice to have you around. Let's start. Question number 1. It says that which of the following is not a fundamental SI unit? So fundamental SI units are basically meters. We also have ampere. We also have Kelvin. We also have seconds. The only one that is not there is what? The radian. Is that okay? So radian is out of it. Okay, so let's look at number 2. A simple pendulum with a period of 2 seconds has its length double. Its new period will be what? So with this, they want us to remember the formula to calculate the period of a simple pendulum. T is equal to 2 pi square root of L over G, right? Now they say if length is doubled, that means if this length is doubled, that means we're going to be having what? 2 pi square root of 2L over G, right? Now given that this is T new, will be equal to square root of 2 times T. So I don't want to go over the derivation so that will not take too much time, but this is it. So the new period will be square root of 2 times T, and in that case you have square root of 2 times how many seconds? Well, they gave us 2 seconds, so times 2, and then when you multiply square root of 2 times 2, it's going to give you 2.83 seconds, right? Yeah, that's what you are going to have. So our answer is what? D. All right, let's look at number 3. Number 3 says which of the following statements are true about the spring balance and the chemical balance? Now we want to see, what do you use a spring balance to do? A spring balance is always used to determine things that has to do with measuring of weight, right? So the spring balance works on the principle of Hooke's law, while the chemical balance works on the principle of moment. That's one aspect. Then another aspect is that let's see, both are to measure the mass. No, both are not to measure the mass. Either of them may be used to measure the weight. No. The next one is a change in gravity changes the reading of a spring balance, but not that of a chemical balance. Yes, this is also absolutely correct. So if you look at the options, the perfect option is what? Option C. All right, good. So let's go to question number 4. Okay, so looking at question number 4, let's enlarge it a bit so that we can see it clearly from afar. Okay, so question number 4 said, which of the following type of motion are oscillatory? We want to see the motions that are oscillatory, right? Now let's see. The first one say a driving boat when used by a driver. Yes, when you are driving, that's a diving boat. This is supposed to be diving, don't mind, there's typographical error. Diving is oscillatory, so that's one, because you oscillate, right? You just move. Oscillation is like the movement of a pendulum, right? So pendulum moves like this, right? This way, this way, this way, this way, like that. Yes. So that kind of movement is what we're talking about here. So divers, they undergo that. The next one that we'll look at is the motion of the balance wheel of a wristwatch. Absolutely, that's also oscillatory. Then another one is let's see, the motion of the turntable of a record player. record player. No, that's supposed to be a rotational because it rotates like this. Yeah, so that's rotational, right? So that's not oscillatory. Then the motion of a center of a 10 kobo piece as it rolls down an incline. That one is also rotation. And then the motion of the needle of a DC ammeter. Yes, this one also it's what? Oscillatory. So we have 1, 2, and 5. So D gives us the right answer to that question. Okay, so let's look at number 5 together. Number 5 gives us a very interesting velocity time graph. It says the graph figure 1 above describe the motion of a particle. The acceleration of the particle during the motion is what? So acceleration is just this distance, this velocity that is covered over the time that is taken, right? So you can just make it like a triangle this way. So in that case, how do we go about it? So what is our velocity? So if you look at the velocity from this point, we have 2, and then okay, first of all, when we have 2 here, then going up to this portion here, this one is number 5. We don't put it into it. So this is like 11, right? Or let's see, if this is 8 and this is 10, then between it should be 11. So this will take us to 11 minus 2. So we have acceleration is change in velocity over change in time, right? So change in velocity now is going to give us 11 minus 2 all over. The change in time is 2 minus 0. It starts from here and ends here. So we have 2 minus 0. And in that case, we're going to be having 9 divided by 2, which gives us 4.5, right? So we're supposed to have 4.5. So looking at the option, the one that is close, because I'm feeling this is a kind of a drawing error. Yes, I was thinking maybe it should start from 0 and gets to 10, possibly. Yes, because I'm feeling this error. So possibly from that point, then we can have 10 minus 0. So it will give us something like 10 divided by 2 minus 0. That will give us 2, and that will be 5. But I don't know, the options here are not even rhyming. So possibly the error is somewhere, but I can't trace it based on this since I wasn't the one that set the question, right? So in that case, we'll just apply this value and then we'll use 4 meters per second square as our answer, right? Meters per second square. Okay, so let's look at number 6. But what you are expected to know in this question is that whenever you are asked to find the acceleration, you find the change in velocity divided by the change in time, and that will give you your perfect answer. Now let's look at number 6. Number 6 here said, if a car starts from rest. Now this is starts from rest. You have to be very careful. Observation is that whenever any object start moving from rest, that means the initial velocity is 0 meters per second and moves with a uniform acceleration. This is acceleration. A is 10 meters per second squared, right? For 10 seconds, this time t is equal to 10 seconds. The distance it covers in the last 1 second of the motion is what? So we're going to be looking for the distance, right? Distance is question mark. Okay, so in this case, let's look at the conditions very well. Whenever a body starts from rest and have acceleration covering a particular time, we know that can be calculated using the following. S is equals to very important for this formula and be applying it at all times. Half gt squared. This formula is very, very important for our calculation in many cases. So let's look at it critically. So half gt squared, g was also given as 10 squared, right? So this divided by this will give us 5. So 100 times 5, that gives us 500 meters. Now the first time it's 500 meters, that's for the 10 seconds. Now they say we should find the distance that it covers in the last 1 second. So in the last 1 second means 10 seconds of that time minus 1, that gives you 9 seconds. So we are going to be using 9 seconds now. Now in that case, so the final distance at 9 seconds will be 1 over 2 gt squared, right? So we have 1 over 2 times 10 times 9 squared, and this divided by this, that gives you 5. So 5 times 81, what are you going to have? 405. Yes, from our calculator we have 405 meters. So the distance now will now be 500 minus 405. Yes, and that's going to give you what? 95 meters. So look for 95. Where is 95? Yes, A. That is our answer. Yes, you can log this in. You can pause the video and copy the solution. It's good for you. All right, so let's go to question number 7. So for the sake of this video, I'm going to be stopping at question number 10, right? So question number 7, let's see. Question number 7, a block of mass 2 kg resting on a smooth horizontal plane is acted upon simultaneously by 2 forces, 10 Newton due north and 10 Newton due east. The magnitude of the acceleration produced by the forces on the block is what? So this one, if we want to look for the magnitude, we take the square root of the first force squared, just like we are doing Pythagoras theorem, and the second force squared, and that's square root of 100 plus 100, and that gives you square root of 200. Now using our calculator, what is the square root of 200? That gives you 14.14 Newton. Yes. So now the question also say that a block of mass 2 kg resting on a smooth horizontal surface acted by this force. Now the magnitude of the acceleration produced by the force on the block is what? So we are going to be looking for the acceleration. Now since the mass is 2 kg, so acceleration is force divided by mass, which is what? 14.14 divided by 2, and acceleration will give you 7.07 meters per second squared. Yeah, that's what we're going to have. So if we look at these options critically, the only one that works there is this option B. All right, let's go to
this mu is the coefficient of what? Friction. And then the coefficient of friction will be equals to F divided by R. And then let's look for our F. Our F is giving us 8 Newton, but then our R will be mass times acceleration, so 5 kilogram times 10. Yes, so it is 5 times 10. You know, acceleration. Right. Okay. So let's look at question number 10. Let me erase this so that to be clear. Question number 10. Two masses, 40 gram and 60 gram respectively, are attached firmly to the ends of a light meteor. The center of gravity of the system is what? So we have to look for center of gravity. Now the simplest way to find the center of gravity is done this way. So center of gravity X is going to be what? 60 times 100, which is the total length of the meteor, divided by 40 plus 60, which is the two masses that are given, right? Now this is going to give you what? 6,000 divided by what? 100, and that's going to give you what? 60 centimeter. So if you want to get the center of gravity, just the larger mass, you multiply by 100 divided by the total distance. Total mass is 40 plus 60. That gives you 100. That will give you 60 centimeters. So to do that properly, you now say that center of gravity is 60 centimeters from the lighter mass, 60 centimeters from the lighter mass, which is this 40. That is 40 centimeters from the heavier mass. So from the heavier mass, it is 40 centimeters. So to get the actual center of gravity, you have to do what? You have to say 100 minus 60, and that gives you what?
40 centimeter from the heavier mass. Yes, so it has to be 40 centimeter from the heavier mass. So that answer gives you C. Yes, please don't go and take 60 because you just found I got 60. You have to take 60 away from 100 so that you have 40 centimeter, and that 40 centimeter is not from the lighter mass. No, it can't be. It's from the what? Heavier mass. Okay, so this brings us to the end of this series. Please remember to like, to share, and to follow. Then on our YouTube channel, make sure you subscribe to our YouTube channel, and that is the name. Yes, TM Pro Academy. Just search for TM Pro Academy on YouTube. Make sure you subscribe, follow, share, turn on your notifications so that as I post wonderful videos like this for your JAMB. Remember, we also do JAMB, WAEC, NECO, and even international exam, IGCSE, GCSE, A-level, ASAT. Everyone, we are here for you. And we do maths and sciences, maths, physics, chemistry, and further maths, higher level maths. I love you, and I wish you the very best in your forthcoming exam. See you when I drop more videos. Bye.